I go to pi over 2. I go to pi, 3 pi over 2, and then I go back to 2 pi. What's the value for sine at 0? 1. What is it at pi over 2? Oh, excuse me, I'm sorry. 0. Sine. I'm thinking close to
Right.
What's sine at pi over 2? It's right in front of you guys. Seriously. What's sine at pi over 2? It's right in front of you. 1. What's sine at pi?
0.
What's sine at 3 pi over 2?
Negative 1.
And then back at 2 pi.
0.
What's happening, again, as you're graphing these out, the value of sine and the value of cosine, for that matter, never gets larger than 1, never gets smaller than 1. The height at which a curve is drawn is called its amplitude. The maximum value or the minimum value. How high up or how low does it go? That's the amplitude. The time it takes to go through one revolution is called the period. The period here is 2 pi. It starts at 0, it stops at 2 pi. Halfway is pi. Halfway between that is pi over 2. And halfway between these two are 3 pi over 2. Again, sine starts at 0. It goes to its maximum value, the amplitude, the A value, excuse me. Drops back down, goes down here, and back. Now all those other values of sine, as you're going through them, root 3 over 2, root 2 over 2, 1/2, all those as you're coming through and around, all match into that curve as well. When we get into graphing sines, cosines, and tangents, we're really only concerning ourselves with quadrantals as we go along, because it's easier to work with. Same thing with cosine. When I'm working with cosine, at 0, what is cosine equal to? 1. Start at 0, go to my quadrantals. Cosine starts at 1, goes to 0, negative 1, 0, and back to 1. 1, 0, negative 1, 0, back to 1. It's going all the way around the circle. The time it takes to go all the way around is the period. It's 2 pi. And again, as you go to plot these things out, it's nothing more than working with fractions. Cosine never gets larger than 1, never gets smaller than negative 1. Guys, worry about that later. Okay. And it just works itself through. Then it makes another curve. And what we're working on today is what we're going to call the parent function for sines and cosines. We're going to work with what are called their amplitudes, their periods, move them. They might get longer, skinnier, taller, squattier, one of those 3 or 4 things. Yes, sir?
So you say parent functions. Does that mean we're going over like H and K's or asymptotes?
Yep, we're going to worry about the H's and the K's and all that stuff tomorrow. Today we're just going to work about the A's and B's. So what we're working with today is basically these 2 things. We're working with when we're working with these things here, you have this generic function. Y equals a sine b of x, or y equals a cosine b of x. those A's and B's mean the same thing for both of them. This value of A, your amplitude is denoted by the absolute value of A. The reason why they say the absolute value, because sometimes you can have what's called a reflection in the sine or cosine graph, it just means it goes the other way first. If I'm talking about the amplitude, it's just how high up does it go from 0 or how low does it go from 0. The B value helps you to determine what the period of the function would be. The period for both of these guys is denoted by 2 pi divided by the absolute value of B. So what we're going to be able to do is take a graph or take a function that looks like this, y equals 1/2 sine of 4x, and be able to plot and graph that by just plucking out the A and the B. So let's do it. When I'm looking at 1/2 sine of 4x, what's my value of A? 1/2. What's my B value? So we've done graphing and shifting many times so far this year. We always label out everything we can first. It just makes our lives easier. If A is 1/2, what's the amplitude? And what's your period going to be? Pi over 2, very good. It's 2 pi divided by 4. So I get pi over 2. So here's where the trickiest of everything that we're going to deal with over today is going to be when you're working with your period and it's not a clean fraction. That's the toughest part that we're going to work with. Every one of these graphs always starts out the exact same way. You make a chart that looks like that. You know that you're always going to label out your amplitude and your period first, because it's the easiest stuff to work with. The highest value I'm going to have is positive 1/2. The smallest value I'm going to have is negative 1/2. So I put them there. Doesn't matter where they have to be, they're just there. I know that my period is pi over 2. So the last number out here is pi over 2. These always start at 0. So now it's just a matter of finding some breakpoints. What's half of pi over 2?
Pi.
Half of pi over 2 is pi over 4. What's half of pi over 4?
Pi over 2.
And then what's between pi over 4 and pi over 2?
Pi over 3.
3 pi over 8. Again, that's going to be the trickiest part for you guys, is to get your half points. This is a sine graph. Sine always starts at 0, goes to its A value. So does this one go up first or down first?
Up.
Yeah. So I start at 0. I go up to the A value, back to 0. The opposite A value, back to 0. There's your graph. Again, the important thing is to be able to label the points on the period. Because when we get to the shifting part of this, we're going to label out the actual ordered pairs. So as long as you can figure out what your period points are going to be, those break points, the rest of this is a piece of cake. What is the maximum value here? 1/2, good. What's the minimum value? Negative 1/2. What are your x-intercepts? 0. Again, there's 0, pi over 4, and pi over 2 would be your x-intercepts. Those are, I'm just looking at, they're basically your 5 main points that you're going to plot for every one of these. Every one of these graphs can have the same basic shape, just in different ordered pairs. Yeah.
How do we know, like, exactly, like, how do you know that pi over 4 is on 0? Are we just following the same pattern everywhere?
Yeah. always work. And I could give you the whole drawn out definition of all of it if you like. What's happening is, again, it's all based off of the unit circle. Now I press the button. It's all based off the unit circle. If I'm looking at sine, it goes 1, 0, 0, 1, negative 1, 0, 0, negative 1, going all the way around. You agree? The period it takes to go all the way around a circle is 2 pi. If all of a sudden I say that the period to go around in a graph is at pi, that means all of these points that are occurring cut in half. This would occur at pi over 2, this would occur at 3 pi over 4, and so on, or however it goes like that. What you're doing is you're working with the period. You're working with this period where all this mungo jumbo is going on by adding in your pi's over 2's and stuff like that. And I never bother going through all of that. There's really no reason to. If you go through and just watch how the sign never gets larger than 1, never gets smaller than negative 1, and it cycles itself through these maximum values. The only thing that's going to change is the period, the ending period, and then just cutting the quarters. That's all you're doing. Let me show you another one. If I say y equals negative 2 cosine of 1/4 of x. Again, what I'm going to do here is just label out what I have first. I know that I have an a value of negative 2, a b value of 1/4. If my a value is negative 2, what's my amplitude? 2. My period, and this is where people will mess up, is 2 pi divided by 1/4. So it's 8 pi. One of the tricks here, guys, anytime your b value is fractional, just multiply by the reciprocal to get your period. Okay? Just multiply by the reciprocal to get your period. So I know that my period is going to wind up being 8 pi. So instead of taking 2 pi to get around 1 revolution, it takes 8 pi to get around 1 revolution. So my last point out here is 8 pi. Oops. What's halfway between 0 and 8 pi?
4 pi.
4 pi. What's halfway between 0 and 4 pi?
3 pi. This is easy.
What's halfway between 4 pi
6
and 8 pi? My amplitude is 2. But my a value is negative 2.
You start down.
Correct. So this is a cosine graph. Cosine always starts at the value of a. In this case, the value of a is negative 2. It starts at the value of a, goes to 0, opposite value of a, 0, and back to a. There's your curve. So a couple things to remember. Sine, 0, a, 0, negative a, 0. Cosine, a, 0, negative a, 0, a. That's the pattern every time for this. And it'll always work out nicely like that. Until we start shifting. But when you shift, though, you still have to plot the parent function to figure out what points you're moving off. Okay. So my ordered pairs here, if I wanted to list out my ordered pairs, I'd have 0, negative 2, 2 pi 0, 4 pi 2, 6 pi 0, and 8 pi negative 0. Everybody agree on that? X's and Y's. Ordered pairs become pretty important tomorrow when we do our shifting. It's very easy to do your shifts off the ordered pairs instead of trying to translate it on the graph. It's very, very easy. All right, graph that. Like I said, most of this stuff shouldn't be horribly scary. Your A value is 2. Your B value is 3 pi. That means your amplitude is 2. Your period is 2 pi over 3 pi, which is 2/3. So now again, the trickiest part with these types of problems is going to just wind up being how do you get your breakpoints when your period is 2/3? Well, what's half of 2/3? 1/3. What's half of a third? Good. What's between 1/3 and 2/3? Good. My amplitude is at 2. One of the nice things is when you're working with these weird fractions, once you get between 0 and your midpoint, you know it's 1/6. Think about that next one as 2/6, 3/6, 4/6. Work through it that way. Sometimes people, especially because this is like a non-calculator style problem, which, oh yeah, quiz this week. We might as well discuss what we're going to do this week. Today we're going to do the sine, cosine. Tomorrow we'll shift them. And then Wednesday we'll spend the whole day on tangents. Thursday we'll tie it all together, some extra problems, and then Friday we'll quiz out of it. Yes, ma'am.
For the fractions, like say we don't have them in simplest form on there, like instead of 1/2, if we did it easier, we did like 3/6, because we were just thinking of like.
You know, I think that's not the end of the world, but if I ask you for the ordered pairs,
Then
because
you're gonna want to
yeah,
see.
because what's going to happen here when we get into the shifting and we list out the ordered pairs for all of it, it's going to be it's going to be a lot easier to see it in simple form. And I'll put it in instructions. So again, this was a sine graph. Sine starts at 0, goes to your A value, 0, opposite of A value, 0. And there's your curve. Okay. Again, hopefully not frightening.
Almost like a ghost. It's just kind of like Casper. Casper. What's it? Casper.
Stop it. Just give up.
This is hilarious. Murph doesn't understand our jokes.
No, I just
Because they're math jokes.
that's the whole thing. Yeah, it's not.
Yeah. They're math.
It's not as funny as what you guys think it is.
They're math jokes, don't you get it? We're in math. That was a math joke.
Here, do those two, please.
I thought that was our.
So you get period for 2 is 2 on that first one?
Yeah.
Okay. So when you go to mark off your graph, does it matter that there's no pi's in it? That's all you have to write it out as. There's just no pi. Your amplitude or your A value is 1/4, so it's only going to go up to 1/4 or down to 1/4. Starts at 0, works its way up and around. Again, relatively straightforward. 5 cosine of 2/3 x. Well, my A value is 5. My B value is 2/3. So that gives me an amplitude of 5. And a period is going to equal 2 pi times 3/2. What I did there is I just multiplied by the reciprocal since it was a fractional amount. Instead of writing out 2 pi divided by 2/3, by writing it as the fraction, sometimes it simplifies quicker. So that gives me a period then of 3 pi. Okay? Not so bad?
And
So when you go to mark off this one, it starts at 3 pi. Here's 3 over 2 pi.
And 3/4 pi.
Between, what's between, yeah, so 3/4. 3 pi over 4. And then what's this one?
9 pi over 4.
Cosine value starts where? Yeah, just at A, good. Starts at 5. 5 looks like about there. There's -5.
Oh, it's just cosine. I didn't even realize.
Whatever, it's close enough. So what's going to happen then tomorrow is that we take these A's and B's, and we're going to throw in the H's and the K. What did the H stand for?
It was. Yeah.
The what? The horizontal shift of the K was?
the
Vertical.
vertic.
So what's going to happen is we're going to take a graph that looks like this. I don't know, sine of 2x minus pi over 2 plus 3.
3 is K.
3 is the K. What's the H value?
Pi over 2.
Is it pi over 2 or is it negative pi over 2?
Negative pi.
Negative pi over 2.
It's positive.
Positive pi over 2. Yep.
Oh,
Just like
I
we've
forgot.
always done. H's and, remember I always said that H's and K never change? So what's going to happen here tomorrow is that we still start our graphs the same way. Our A is 2, our B is 2, our H is pi over 2, and our K is 3. That gives you a period of pi. Everybody agree?
Yeah.
So if I'm starting at 2, so you have those 4 points like you normally would. 0, 2, 0, -2, and 2. That means I have to move all of those points what direction?
Up 3 and
Right.
right.
Everything has to move to the right pi over 2, and they all have to move up 3. So what we're going to do here is 2 ways of doing this. I know my ordered pairs are 0, 0, pi over 4, 2, pi over 2, 0. Just for a rough idea. To that I have to add pi over 2, bless you, and add 3. So the new ordered pair would be at pi over 2 and 3.
Yeah.
Oh, yeah, pi over 2 and 3. And then pi over, then it would be 3 pi over 4 and 5. It's just moving itself up.
So we just moved it over to like 3
Yep.
for this particular graph.
So this just gets shifted up and over. It's relatively straightforward. It's based off the same parameters that we're talking about today. Just being able to go through the shift. So now, I will give you some problems. I'm giving you 2 different sets of problems. It's on 836. Yeah, oh well. So on 836, we start at 36. I want you to graph these 5. Don't worry about the tangents yet. I want you to graph those 5. 36, 38, 39, 41, and 43. Right, but they're in front of you. They're highlighted.
Actually,
The other part is I want you to write the equations out. Now, these 6 are ones that you're going to have to write the equation given the amplitude and given the period for a sine function. They're all sines. And in the instructions it says A and B are always going to be positive. So you don't have to worry about these absolute value parts. You won't have a reflected sinusoidal graph. It's just gonna be a regular sine graph. I mean, when I'm saying reflected, it's not gonna go to the negative a first, it's gonna go to positive a every time. So what's gonna happen here? For example, if I'm looking at number 44,
You're gonna-
if my amplitude is 1, what's my a value? 1. Now, the period is 5. That's kind of difficult to worry about to solve for b. I know that the period equals 2 pi over b. So what I have to do here is I have to solve this equation then for b. Then write out a sine b of x. Okay? In this case here, you should probably be able to pick out what b is going to equal rather easily. What's b going to equal in this problem? Do you remember the trick when you have a variable in the bottom?
5 over 2.
Other way. Remember, these two guys are just changing places.
Oh, cross and multiply.
So b is 2 pi over 5.
Oh.
If a is 1 and b is 2 pi over 5, you get y equals 1 sine 2 pi over 5 x. And that's it. Do you need to write the 1? Nope. Excuse me. So do those 5 graphs and then those, well, the other 5 write out equations. That make sense? We'll shift it tomorrow. We'll do all tangents and tangent shifting on Wednesday. Some extra problems Thursday. Call it a day on Friday.
Okay.
All right?
Hey, hey.
There we
Wait,
go.
first, so does that